Okay, now we're going to try some examples. Find the slope of the line that goes through the points 5, 6, and 1, 2. Now, we could graph this and count, but let's try not counting. Let's try using our formula. And remember, our formula for finding the steepness of the line, the slope, is the difference in the y coordinates, y2 minus y1. That's going to represent our rise. And the difference in the x coordinates, remember x tells us how much to move over, so that's going to represent our run. x2 minus x1. And it's really important that it doesn't matter which point we choose to be our 1 and which one we choose to be our 2, but that we always line up the 2's and we always line up the 1's. So let's call this one x1, y1, and let's call this one x2, y2. Here we go. y2 minus y1, 2 minus 6, over x2 minus x1, x2 minus x1, 1 minus 5. Notice that 1 and 2 are a pair and that 5 and 6 are a pair. Okay, so then we just do the subtraction problem. When we do this, we get -4 over -4. And what is -4 divided by -4? It is 1. So the slope of the line that goes through these 2 points is 1. Ta-da! How about this one? Let's try this. -3, 4, and 2, 8. Remembering that our formula for finding the slope is y2 minus y1 over x2 minus x1. And let's call this point x1 and this one y1, and this point x2 and this point y2. So y2 minus y1, y2 minus y1, 8 minus 4. That tells us how much we're climbing from one point to the next. We're climbing up 4. Then we're going to do x2 minus x1. 2 minus -3. 2 minus -3. When we subtract a negative, that's the same as adding, and so we get 5. The slope of this line is 4 over 5. Ta-da! One more example that we're going to do. This one's got a little trick to it. How about the point 3, 2 and the point -12, 2? We're going to find the slope of the line that goes through those 2 points. And we're going to use our formula. Slope equals the change in the y, y2 minus y1, over the change in the x's, x2 minus x1. How much we go up and how much we go to the right. So let's name our points. I'm going to name this one x1 and y1, and this one x2 and y2. And then I just plug it in. So I get y2 minus y1, 2 minus 2, and x2 minus x1, -12 minus 3. 2 minus 2 is 0, and -12 minus 3 is -15. Now, if you had nothing and you cut that into 15 groups or -15 groups, you're still going to end up with nothing. Kind of a weird thing to think about. But this is where actually thinking about this visually comes to be quite helpful. -2, -12, 2, well, that's going to be somewhere over there. 3, 2, that's going to be somewhere over here. What can you tell me about that line? Notice it doesn't rise at all from one point to the next. The rise is 0. We're going over 15 points. That's where that 15 comes from. If we go that direction, we're going back. That's where the negative comes from. But you can tell me, just by visually looking at this, that the slope is 0. So know that you can always go back and think about the line visually, or maybe I should use this one. You can always go back and think about the line visually. This is a horizontal line, but now we have a new tool in our toolkit. In order to find the slope of a line given 2 points, do this. Subtract the points. So our formula is y2 minus y1 over x2 minus x1. If our points, as long as our points are x1, y1, and x2, y2. That's a comma right there. Okay. We're going to come back together and do some example problems.